Well, hi, and thanks so much for joining me here in my shop this morning. I'm getting ready to do the FM alignment on this radio. And just before I turned the cameras on, I was looking for a place to connect two temporary resistors, just as they show here. 200K resistors in series. Now, in a lot of FM radios, these resistors are already installed. They're installed by the manufacturer, but in this case, the suggestion is to install them as a technician like myself. Install them, and then it provides a test point between the 200K resistors in order to generate diagrams that look like this. So this is an oscilloscope diagram. To get those kinds of things, you need these two resistors here. See, there's actually three test points. There's one here, B, C, and A. But here's the thing, the reason I turned the cameras on is while I was looking at this part of the radio closely, trying to figure out where to install these two resistors, I spotted something that I wanted to investigate further, and I thought doing it on camera would be good. It's right up in here somewhere. So we'll use the close-up camera, take a look at it. You tell me what this is. And where is it, Jim? It's way up here. Okay, so when we look in here, let me just get this steadied up here. Right there, dead center, that bare wire. Isn't that a short to the chassis? Now, there's a chance that wire is actually a ground wire anyway. It's bare. So usually bare wires are, where'd it go? Let's see if we can keep an eye on it here. See it up this way maybe. Oh, look. Okay, so I guess if I looked at this a little closer, I would have seen that it's just going to a terminal right on the chassis there. Is that really the same wire? Let's just say the same thing. Yeah, okay, no problem. Got all excited there about nothing. Okay, so let me continue on those with the camera rolling. So in looking at the diagram here showing where the two resistors need to be installed and looking for some place to make a definite attachment correctly, it looks like the electrolytic capacitor here is going to be a good spot to pick off this point, which is where these are connected. So that's what I was looking at. So I'm going to continue with that, see if I can install these two resistors, and then we'll start doing the alignment process. Okay, so I turned the camera back on here to show you something else I've just found. In here, on this circuit diagram are these right here. This says powdered iron sleeve. There's another one here. I think there might be one or two more in this radio. Obviously these are traps for higher frequencies. They can't pass through these. Well, I hadn't seen one of these. What do they actually look like? Well, I finally spotted one, and now I know why I wasn't able to see them. They're tiny. So here's one here. So we're coming off of this kind of a purpley colored wire here, and you come along, and there it is. Oh, it's quite clear in the camera view, but believe me, when you're looking with your eyes, that is hard to spot. And so happens, I think that actually might be the right spot to connect, for me to connect to also. Now there's another one of these in here somewhere, but at least I know what I'm looking for. That's tiny. You think that it's hard to believe that has enough effect to make it worth even doing. Okay, great. Yeah, back to sorting things out here. Okay, I found something else worth looking, I'm still searching for the best place to hook up these two 100K test resistors. And if you trace this back, it's the same as connecting it to pin 2 of this tube. Now we'll take a look in the radio here. Okay, so we'll look for pin 2, which is right on this tube. So pin 2, let's see, I can point to it. So this is pin 1 right here. This is pin 2. And look at it. Okay, in the camera it's a little hard to make out, but that has been resoldered. That's fresh solder on there compared to the other pins. It's not so apparent in camera, but it's very apparent to me looking at it. So I'm going to guess that's where the connection was made by the last technician to put in the two 100K resistors. That's a bit of a tricky spot right in the back of the board here, but I could do the same. And then you have to make them go to the chassis, so I'll bet you this terminal here would serve the purpose right here. So you could put them in there. But I thought it'd be interesting in just showing you. You can see the the tracks of the previous person and what they did. And once again, they appear to have done a pretty good job on this radio. So I think I'm going to follow suit. I think I'll hook up the 200s right in here. I can make them protrude a little bit. It's the tie point you want to use as a test point. So I can make them come out as a V in here, and the test point will be sitting right there. Okay, I'm going to put in those resistors. So I have a large number of vintage and never used components along with brand new ones. I'm normally installing the brand new ones, but occasionally I like to pull out some of the vintage ones. So here's two 100K vintage resistors. Never been used. We'll test them out here on the meter. See if they're 100K. Here's the first one. Almost 200K. Now these have never been used. They've just been sitting in a various parts containers for 50 years or whatever it is. Now look at that one. That one's about half of 100. So you got one that's double and one that's half. I thought that was kind of instructive. I got some more. Even lower. I think the lesson here is don't use these vintage resistors. It's kind of interesting. Here's another one. Should be 100. If one of these comes out to 100, we'll know it's just a random effect. 70. Now, this is really quite unnerving, in fact. 70 again. Most of the time I'm 70 again. Most of the time I'm dealing with radios that are loaded with this vintage resistor. And what I'm finding so surprising here is I always think these resistors are going to go high. They're not going to go low. That's 3K. $3K. Wait a minute. $3,000 ohms. Wow. What happens if you bend these leads here? Huh. Makes me think I'm reading the meter wrong. 3K instead of 100K. Wow. Just sitting here and not doing anything with it. Maybe they've been blasted by cosmic rays or something. So they're all coming out low. Most of them are coming out low. Yeah, let's try a higher wattage version of the same value. Well, that's closer. Just the little tiny guys that are... Here's another one. I got lots of these 100K. 10. Okay. Wow. Let's keep going here. I got more. Another small wattage one. Seems to like 75 a lot. I have done this with some other style of even older resistor, and the results actually weren't that bad. It's kind of close, but again, at this point, wow, it's just a random deal. One of these should happen to come out close. Now, what would make them go low? Must be the carbon. I think these are carbon powder inside. Pressed carbon powder sort of thing. That's close to 100. I'm not going to use it though. Maybe the compression of the powder changes, although you think it would relax. Here's a higher wattage one again. Oh, got one. Small aside here while we do a resistor experiment. Yeah, I'm not going to continue saying that these things always go high, because they're all going low. Oh my gosh, 1K. 2K instead of... So this is 1/50th of what it's supposed to be. Brown, black, yellow. Well, we're pretty much down to the bottom of the bucket here. I think maybe what I need to do is get a good, what I would imagine to be a good one. Just compare. That's pretty close to 100 again. That's the bigger diameter one. Maybe these bigger ones are a little more stable in the long run. I would tend to think the opposite though. I would tend to think the bigger ones are doing a heavier duty in the radio and they're beat up more. The higher wattage resistors are bound to take more punishment in a radio. So my imagination says. But let me get a real 100. Let's try one of these other types here. A real 100. Okay, so I think this is a modern. These resistors have their problems too. I don't like using this particular style here. So there we are, right around 100. The problem with this particular style is they use end caps. It's hard to see here, but there's a cap there and a cap there. And the wire is fused to the cap, and then the cap is pressed on to the body of the resistor. And this pressing it on, it just doesn't work. A little bit of bending, and then bending the wire will flex the cap and rip it right off the end of the resistor. And I've had lots of these go south because of that. You know, maybe using them as a test resistor here is not so bad an idea. I can always install these and then read them to make sure they're correct afterwards. Now it says right in the sheet, a matched pair. Back then, getting a really accurate resistor might have been tricky. So are those a matched pair? 99? Is that a matched pair? 99, where'd the other guy go? Well, I think they're both reading 99. I think that's pretty good. If I can install these two guys without flexing the caps much, they'll be just fine. Now this end's supposed to go to ground. So I was thinking of doing it this way. Boom, boom. Very good. Okay, I'll continue on with installing 2 resistors. Okay, so I've got the 2 resistors soldered in now. I've double checked them, the resistance is okay on them. So we're ready to go with the actual alignment. So to do the alignment now, I'm going to need to set up my FM transmitter back here and a few other things. So I'll get all that organized and away we go. Okay, well, another curiosity is showing up here that I need to check into. So I thought, let's turn on the cameras and we'll do this together. So first, let's take a look at the part here. It's about this electrolytic capacitor. What does the 47 mean? This is supposed to be, I think, a 4 microfarad or 6 microfarads, very, very small capacitor. Now, look how they've done this. The bars on it have a plus sign pointing towards the positive end. So this, whoops, this should be the positive end. Certainly looks like it. And this should be the negative end. It looks like it. You can see the can on the negative end. A lot of these capacitors, I think the arrow points to the negative. But anyway, so quite clearly, negative end of the capacitor is connected there. See, that's a fairly large trace that's on. The size of the trace, if it's very large, sometimes indicates it's a chassis. It's a ground point. I feel like can't really tell just looking at it. Now the other end, well, what I'm worried about here is this capacitor is in backwards. That's what I think has happened. So here, when you look at the capacitor in the background, you see a plus sign. Doesn't that reassure you that plus must be this way? It's kind of like a capacitor herd mentality. Everybody plus this way. So go down under here. Pretty hard to tell what's going on, and this is a blocked area for viewing. It's blocked by that bar there. From underneath, it's really hard to get at and see what is going on. So let's do this. Here, let's take a look at the schematic here with the close-up camera. So the part I'm all concerned about is right there. Oh yeah, 4 microfarad capacitor. Now, quite clearly, it shows a negative connecting to the same line as the test point resistors. You see, that's why I've gotten interested in this. And it shows the positive connected to the chassis. You see, now that's intuitively backwards. Most people would say, yeah, negative to chassis, positive into the radio. But this is after a rectifier that's right inside the radio. And this rectifier could rectify out or produce a negative to chassis voltage or a positive to chassis voltage. Just depends which way you flip it around. And in this case, they flip it around to produce a negative. And the reason you want to produce a negative relative to the chassis is you utilize it for AVC purposes. At least that's what's in my head. And that's why you flip this capacitor around, because in fact, this test point A is being driven negatively by the rectifier here relative to the chassis, because you see that pin 7 is hooked up to the chassis. So I should be able to put my ohm meter on the positive of that 4 microfarad capacitor and read to, 0 to the chassis, 0 resistance to the chassis. So that's what we're going to try. Is the positive side grounded? That is the question right now. I did this just before I turned the cameras back on, and that's what made me turn the cameras back on. The camera. Well, I guess they're all on. Okay, that's what we're hoping to see when I hold this on the chassis and touch this to the positive. There we go, on the positive. Ain't no 0 there. Now if I go to the negative, So, this is pretty convincing. I need a little more convincing. I need to know where the... I need to know that the capacitor's in the right place also. Now the guy who did the work that he did a great job. Getting this backwards is so easy. This would be really easy to do. And it's a fairly low voltage here, so putting it in backwards may not actually cause much of a variation in the operation of the circuit, in fact, but it's really much better to have this thing correctly. I don't think there's any doubt of that. So I want to prove that the negative is connected to the test point. But if it's flipped around, it's the positive that's connected to the test point. So let's go on the positive terminal. And do we get a 0 going here? Oh my gosh, we don't. That's to the chassis. This is to the test point. What? Get right back in here. K ohms. Oh, a little hard seeing that, isn't it? 28K ohms is what I've got, where I'm thinking I should get a 0. Okay, so what about the other end of that? Maybe I'm all mixed up here. Let's try the other end. I saw a 0 there for a moment. Or I saw open, I think is what I saw. Yeah, I think I saw that. 27. What's happening? What's happening here? This situation's even more weird than I thought. So what could have happened here? With the guy who's carefully doing the work, if he put it in backwards, that's one thing. He's put it in the right spot, I would have to think. I have to absolutely prove that the reversed positive side of this capacitor, well, where's it going? What is going on? So maybe what I'll do is I'll clip on to pin number 2 on the tube, and I'll try to find the top of every one of these components, starting with this, starting with the resistors I put in. So that's what I'll do. I'll clip on pin number 2. So I'm clipping on pin number 2. That's going to be... So this is pin number 2. So I've got this clip leads on pin number 2. So we'll go pin number 2. Hook up one lead here. The other one, we should find a 0 first on pin number 2. It sounds like a crazy thing. It almost is. This is clipped to a wire I soldered in on a line of solder that goes to pin number 2. So I'm pretty much checking the continuity of a bunch of solder here. But we should do it. And it looks just fine. Okay, so that's definitely pin number 2. Hey, let's check this resistor again. What do we get? Half the last, yeah, okay. Mumble, mumble, mumble. So the 33K resistor, which is really hard to see. We have the electrolytic, and then we have this 4700 C48, which I believe is the one that appears to be temperature sensitive. Although, it's in the wrong part of the radio to be temperature sensitive. What do we get there? We get that mysterious 27 again. 27. Well, okay, then it's the other side of this resistor should be on, or capacitor should be on the test point. We should get a 0 here. Okay, we're getting a 0 there. So I've proven this spot. Now I gotta find the 33 and prove it. Wait a minute, how does this happen? If I get a 0 here, but I don't get a 0 here, how can that be? Okay, let's try this again. Okay, on the capacitor, 0. Okay, so now on pin 2, if we don't get a 0 there, I would just flip right out. Top, I'm confusing myself. Top of the 33. Now, this has to be. This will be the 33 right here. 0. Okay, so everything is measuring a 0. Top of the positive side of the reversed capacitor. You should see a 0 there. And we get the mysterious 27. There's something more wrong here than something is wronger here than I thought. What's happening? He's resoldered the capacitor in slightly incorrectly. It's got it reversed and incorrectly. Where's this 27 coming from? The 33. The 33 could be 27. The 33 is in parallel with 200. So this could all be 27. So read to here, to the chassis. I'm not reading to the chassis. I'm reading to pin 2. Let's read to the chassis and see if we don't get 33 with 200 in parallel. Okay, I'll take this out of here. Chassis. Same point. And the mysterious 27 shows up, which is probably 33 with 200 in parallel. 27. 27. So, and that's from that point to the ground. So it's all making sense except this capacitor. So, but no, it doesn't. Wait a minute. Let's go back. So I'll put the clip lead back on. So the clip lead is on this spot right here. It's actually up here somewhere. It's on this line. When I check the positive side, it's straight to ground, to the chassis. I should see 0 on the positive and then 27 on the negative. 0 on the positive, 27 on the negative. So put this back on chassis. On the positive side, what? Wait a minute. What? Where'd the 0 come from? That's right. 0, 0, 0, positive, 0, positive. That's correct. Positive. What am I doing here? Going all around in circles. Positive side reads 0 to the chassis. I thought it was reading 27 there a while ago, wasn't it? I think maybe. And the other side, negative. It reads more of a 0. Okay, we got more 0 on the negative. Is this a shorted capacitor? Let's put it in backwards and it's developed a short. That would wreck this radio. That would wreck it. That would put a short right on the output of the. The thing wouldn't work at all. You wouldn't hear anything. Okay, let's put the ohmmeter right across the capacitor. Make sure you know which clip lead you're moving here, Jim. Okay, doing this through a clip lead too. Don't leave me now. Right across the capacitor. Huh. So either he's hooked this capacitor ground to ground, or the capacitor itself is shot, or I am losing my mind. Let's focus on this capacitor some more. Let us focus on this guy here. Just 1 second while I try to make a nice camera shot. See if this is a nice one or not. Not particularly. That's the capacitor down there. This guy. So I'm going to unsolder it. One leg out. And then we'll check it. And we'll see what the size is too. Hey, where are you going, camera? It's a really harrowing camera shot here. This is not going to work out well. While we're letting the soldering iron warm up, let me see if I can get a little better view of the action here. Not really. Okay, so we're gonna pop that one lead there. Did I say dare or there? Okay, that came right out. Oh my gosh, if this shows up shorted, I will what? Well, I should be happy because I will have found something quite significant, but really, if I had to put a wager on this, I have to wager this is not shorted. There's something else going on. Okay, we'll put the negative on the negative. Positive on the positive. So that's 100K there, going up. It slowly charges up. I don't think that really registers as bad. It's really not a dead short. .35 volts, 100 microfarads. 100 microfarads. And the schematic is calling for 4. You know, I think the purpose of this capacitor is such that going up in size really wouldn't matter. In fact, bigger it is, the better it is. But somewhere there's a limit. If the designers say 4 is good enough, then 10 would be as far as I would want to go. What this capacitor is responsible for generating a 90-degree phase angle in the current flow in here versus the current flow, not in there, current flow in here versus the current flow in here. If you can follow any of that. So you put a bigger and bigger capacitor here, once it's shifted 90, it's 90. It's not going any further. But it sure strikes me that, I mean, one of the reasons they wouldn't put 100 here is because 100 costs a lot more than 4. That'd be about 18 extra cents per radio. And they wouldn't want to do that. So that's why I think 10 would be fine in there. But 100, 100, 100, and in backwards. I'm still not convinced I got this thing backwards. I guess another way would be to operate the set and read the voltage across it and see if it's positive or negative. Hey, you know what? That's a pretty direct way of doing it. I like that. Only thing is I've unsoldered it. So let's stick it back in. We'll solder it back in. We'll run the radio, find out what's going on here. Okay, I run the risk of burning my finger here. Okay. Oh, popped right out. Okay. So we put it back in, way too big and backwards. Way too big and backwards. So we want to set up a voltmeter here. We want to do this like a quick reading. We don't want to drag on. And I'm going to use my ungrounded isolated meter here to do this. We'll anticipate 20 big volts. And we got to set this up now. So positive, well, let's do this. We'll do this in accordance with the markings on the capacitor. The positive here. This way you get a positive reading, it's capacitor friendly. And the capacitor is in the right way. That's what that would tell us. You get a negative reading, well, then all this monkey business was well worth it. Okay, double checking now. Positive side of the capacitor has a red lead, red into the positive, black going on the other side, just across the capacitor. And to get a voltage there, well, I guess, you know what, it's going to generate a small voltage even if there's no signal. But, you know, we have the speaker hooked up, but I stick an antenna on the, you know what I've got 10.7 racing into this radio right now. So we can actually utilize this guy here, 10.7. Did I say 10.7? Let's make it 10.7. So 10.7 should leak through the IF, come out the speaker, 400 hertz modulation. We should hear this. We should hear it. Okay, you want the radio on FM. Okay, it's on FM. Volume is, get it backwards now. Volume is down. And it's tuned to who knows what. I think we're ready. Once again, positive voltage here indicates the capacitor is actually wired backwards. Good means bad. There we go. Okay, the light's on. Yeah, pilot light, everything's good. Tube's warming up. Going the other way now. What I meant by that was I'm turning up the voltage. Yeah, we're getting a positive reading. And some sound. The capacitor is wired backwards. Let's see if it varies here. Yep. Let's see. Let's do this a little better. Doesn't seem to want to vary. Doesn't vary any. Pretty distorted stuff, huh? Okay, Let's shut down. Hang on a second. How did I convince myself that a voltage in the right direction on this capacitor meant the capacitor was backwards? If we're getting the right positive voltage. Oh my God, what the heck is going on? I got myself all... Something more going on in this radio? So I just read, you know what we got to do? We got to check the test point here, voltage to ground, point A to the chassis. It should be driven negative. Okay, we have to do that now. Test point A to the chassis. It's off. Test point A. Maybe I didn't get test point A right. Okay, so I'm on test point A. Test point A should be driven negative. Got the meter hooked up right, the common black lead and the common onto the chassis. So we should get a negative reading here if this is driven negative. Okay, here we go. Let's let her rip. It's going negative. Then if the top of the capacitor is connected correctly, there should be no voltage between the negative side of the capacitor and where I have this red clip lead. Oh my God, I'm just going around in circles here. It should be 0 there. It should have essentially connected just across this wire. It should be a 0. Something's going on. So it says right here the voltage here should be minus 0.8. What are we actually measuring? Right now we are measuring test point A. To the chassis. Let's go to the chassis. Test point A to the chassis is minus 0.5 and it should be minus 0.8. 0.8 with no signal. Maybe it's 0.5 because this reversed capacitor is leaking out too much stuff. So how did I get a positive voltage on this capacitor? What the heck? Okay, let's try this again. Let's try this again. Take this off. Right on the capacitor. Positive side. Negative side. Get a positive reading. Positive reading of 6 volts. Six volts across a capacitor where we just read 0.5. Where's the 6 come from? Wow, okay, there's something going on in here. I don't know what exactly, but wow, what a schmaltz. Um, for sure, I'm reading. Okay, so once again, if the capacitor is in backwards, then the reading I'm taking is to the wrong spot, but it should be 0. Shouldn't it? What am I doing? I'm going across the capacitor. Okay, shut the set off. Shut the set off. Let's start over here. Okay, from the chassis, reading resistance to the side of the capacitor that should be connected to the chassis. You know, I'll take that back. That's the side of the resistor that is not supposed to be connected to the chassis. What is going on in this radio? So maybe the schematic isn't correct for this. So I have a capacitor that appears to be connected backwards, yet is developing the correct voltage. The correct voltage polarity. The voltage amount is way off. How do you do this? How does this happen? Well, I did have a plan to do something today. I'm not sure I'm going to get there at this rate. I think I'm going to have to pick through all the little circuitry in here and verify that everything is the way it's supposed to be. And I see the fellow did a fair bit of work up in here. Yeah, there's more things mixed around here than I realize. Okay, I'm not going to do all that on camera because it's going to drive everybody nuts, including me. I'll be driven nuts. I'm already nuts. I've been driven nuts. Let's see what I come up with. Okay, mystery solved. I got this absolutely and completely wrong in my head. So the big capacitor here with 100 microfarad capacitor is correct. It actually shows up down here. It's the bypass capacitor for the output tube's cathode resistor, which of course on the diagram here are far apart, but on the radio the output tube is right here, is right next to where we're fooling around. So that's what that capacitor is. It's absolutely correct, and 6 volts across it is correct. And right on here it says 7, and we're getting 6 across the 180. That's perfectly fine. So what that tells me is that this capacitor, the 4, is this other one that I thought was some kind of temperature capacitor because it has some temperature numbers on it, like a temperature compensating capacitor, but there's no way this is a temperature. Well, I won't say that. I believe you put temperature compensating capacitors in the front end to compensate for variations up here. You don't do it way down here, I don't think. So now what I'm faced with is this capacitor gone bad? And I should go in there, get it out, put another one in. I can certainly do that. Or is this a special capacitor of some sort? When I looked in the parts list, which I don't have printed here, but I looked in the parts list, it just shows up as an electrolytic 4 microfarad capacitor. That's all. So what to do? What to do? What to do? Should I replace that guy? Well, let's take a closer look at it. That's a good starting point. Take a closer look, see if we can find more identifying stuff on it. Just a sec here. There. Hey, what happened to my camera? The focus just go wild. Let me adjust it. So here's what we see. We see a 41.173A. That's somebody's manufacturing number or part number, storage number. There's the 70. So it says minus, oh, this is the temperature range of this capacitor. It goes all the way from minus 20 to plus 70. That's all that is. You know, they make the connection there and they just crimp it down on. I think there's nothing special about this guy. So we're going to change him out. We're going to stick a 4 in there. Actually, it'd be better. Let's try testing it in place. And then we'll lift one lead and test it again. Make sure we really test this thing thoroughly. Sounds like a plan to me. Now I got a couple ways of testing him. He's in the circuit here. I think it's bad. Well, let's see. It's paralleled with another smaller capacitor. It's because the electrolytic ones they don't work well at a higher frequency. So sometimes you'll have an electrolytic one, and then a regular one paralleling it just to help with the high frequency stuff. That's probably what's going on there. But this capacitor has this 33K resistor right across it. So I don't see how we can test it in place. So I'm on my way to replacing it anyway. So let's lift one leg out of there and test them that way. That'll be a proper test anyway. This is a tough spot to work in. Doesn't want to pop out. Up here. Sometimes you got to add a little bit of solder to get these guys to come off. Going on here? It does not want to come off. It's because I'm unsoldering the wrong thing, of course. I think I'm after. No, I'm not. I'm doing the right thing. Okay, we're going to replace this capacitor no matter what. I'm going to cut it and leave the lead behind. It's so uncooperative. Oh! Let's test that capacitor out. See what we get. I think I'm going to have to use my big guy tester. Okay. Wow, I didn't get anywhere doing an alignment today. What? What? Turn that to electrolytic. Now we'll just pick the leads right across the capacitor here. Okay, so first thing we're going to do, this was a small capacitor. I couldn't do it with these long leads, but it's a big capacitor, so it'll work 25 volts across it. What is the rating on this? This is a low rated capacitor. It's not even rated for 25 volts. I think it's rated for only 12. Well, it's going to get 25. Here we go. Watch the eye. Pop right open wide. So that says no leakage. Okay, well, we'll try measuring the capacitance. It's supposed to be 4. Should find it here somewhere. Way down here, and I'm on the 0.1 scale. Oh my gosh, so 4 is up here. Anytime you use this instrument, you get readings right at the end of the run. That's basically invalid. Or of no value. Maybe that's the way I should put it. You can't probably see it in the camera, but there's funny shadowing things that happen in this eye. Did I really get this right? 0.1 to 50. Well, here's the 50. 50, 10, 5, 4. Well, the capacitor is proving to be a complete and utter dud here. Let's try this leakage thing again. Almost gives me the impression my leads are open. Let me just double check that possibility here. I'm using lousy test leads. The reason I suspect that is because the capacitor on the leakage test reacted so fast as to pick up no charge. Now it's also telling me there's no capacitance in this thing. I think maybe those two go together, but let's see what happens. Now, a different set of leads. 25. Exactly the same behavior. Go back to check it here. Exactly the same, even the same wishy-washy stuff in there. Okay, so this capacitor appears to be a dud. A dudden. Okay, maybe this long kind of convoluted journey has ended up somewhere useful. So what I am going to do is I'm going to remove it and put in a brand spanking new one. Let's get them out of there. And we get a good look at it finally. What's all that? It's up against the tube base, so I guess that's a little bit of heating from the tube base. 4 microfarads, 70/80 volts, 20 to 70 C. And the part number, and that's all it says. So nothing special about this. I was nervous at first, thinking this was some kind of spectacular capacitor. It's not. Okay, so we need a 4. I think we would stick with exactly what it calls for. A 4. Let's see if we can find a 4 down here. Four. $47. Okay, I'll hunt down a capacitor and we'll stick them in. Okay, just soldering in the last lead on the new capacitor here. Lots of smoke. There we are. Okay. I think we should give this guy another try, another shot. See what it sounds like now. That may have made a very big difference. So you see, the whole time, right from the time I first looked at this radio, I interpreted this capacitor as being something like a 5 or a 10 microfarad involved with, of course, the this position here in the detector. I couldn't see the size of this capacitor. I made a bad assumption. It's okay. It's good though. That's a good capacitor to have changed out. Once again, the last guy doing a good job, but he didn't bother with this capacitor. Maybe it was okay back then, or maybe the radio sounded good enough, because it actually does work. Let's see if it works a lot better now, because this could make a dramatic tonal quality. There's a lot of distortion in the FM reception before. I don't know if you were hearing it the way I was hearing it. Okay, now let's just double check everything's okay. We're still feeding a signal from the signal generator at 10.7 into this radio. Volume down. We're ready. Do I need to measure anything right at the moment? No, we're just going to listen to it because my day is done in here. Okay, power on. Okay, good response on the dim lights. There we go. Come on, baby. Full volume. Yikes. Now, I think I'm pushing 10.7 into this. Why we're not hearing any of it? This is on FM. Let me fiddle with this. There's part of the reason. Instead of 10.7, it's 10.65. So I think the IF is out on this. Okay, we'll tune this away. Now, I'm going to leave it just as it is. We'll see if we can tune in a station even with these wires connected. What are the chances? That's the... Oops. some reason the signal generator was there. Come on, give me something strong here. Well, I think it sounds better. It's still got trouble, obviously. It's got some alignment issues, I think, at this point. But I think the sound quality is actually a little bit better. So that's what's in store. And tomorrow, I'll get in here. Now we're ready to do the alignment. I've cleared my head. Listen, I've emptied my head, and I'm ready to go. So that's what's up for tomorrow. Thanks so much for watching this kind of wandering around craziness, but sometimes, you know, you're going to search for certainty. It's hard to find certainty. Think about that. See ya.